Here's problem 2111. During the volcanic eruption of Mount Pelée in 1902, an incredibly hot burning cloud rolled down the mountain and incinerated the town of Saint-Pierre. From the damage done, the temperature in the cloud was estimated at 700 degrees Celsius. If the air temperature was 20 degrees Celsius and the molecular weight of air is 29 grams per mole, estimate the molecular weight of the gas in the burning cloud that made it heavier than the surrounding air. As a follow-on, estimate the most probable composition of the cloud. Okay. In general, root mean square velocity of the gas will be equal to 3RT over the molecular weight of the gas. For this problem, we were going to assume that the air and the gas have the same root mean square velocity. So that VRMS for the air is going to equal VRMS for the gas. So we're going to have that 3RT for the air over the molecular weight of air, square root, is going to equal 3RT for the gas over the molecular weight of the gas, square root. Let's square both sides and get rid of a 3 and an R, and we are left with that the temperature of the air to the molecular weight of the air is equal to the temperature of the gas to the molecular weight of the gas. Hence we can say that the molecular weight of the gas is equal to the temperature of the gas over the temperature of the air times the molecular weight of the air. This is going to be equal to, temperature of the gas was 700 degrees Celsius. We need to convert that to Kelvin, so we're going to add 273.15. And the temperature of the air was 20 degrees Celsius, so we added 273.15 to that, times the molecular weight of the air, 29 grams per mole. So this is going to be 973.15 over 293.15 times 29, and that is what? 96.3 grams per mole. That is the molecular weight of the gas, of the burning cloud. Alright, we have some possibilities for what this gas might be. Hydrogen sulfide, sulfur dioxide, sulfuric acid, H2SO4, carbon dioxide, and nitrous oxide. Let's take a look at these possibilities. Hydrogen sulfide. Hydrogen has an atomic weight of 1, or a atomic number of 1, giving us atomic weight of 1. And sulfur is 32. So we're going to have 2 for each hydrogen plus 32. This has 34 grams per mole. Sulfur dioxide. Sulfur is 32. Oxygen is 16. So sulfur dioxide will be 32 plus 32, 64 grams per mole. H2SO4, sulfuric acid. We have 2 hydrogens, so 1 for each of those. Sulfur, we have 32. Oxygen is 16. We have 4 of those, so that's going to be 32, 64. So that is going to give us 98 grams per mole. Carbon dioxide. Carbon is 12. Oxygen is 16. We got 2 of those, so that's going to give us 32, 44 grams per mole. And finally, nitrous oxide. Nitrogen is 14, oxygen is 16, and it's going to give us 30 grams per mole. Looking at this, the most obvious candidate is H2SO4, sulfuric acid. That compares well with the molecular weight of the gas, which was 96 grams per mole. So it's very likely that a lot of that gas, most of that gas, was H2SO4, sulfuric acid, and hence it truly was a burning cloud and more than just temperature.